I like to visualize Dalton's atomic model as being a shopping cart model. That the shopping list for hydrogen peroxide will always consist of 2 oxygens and 2 hydrogens. But it doesn't tell us a lot of other things. It's pretty good, but the model had some definite missing pieces. For example, let's see, it couldn't explain, well, why do we have to have 2 hydrogens and 2 oxygens? Why couldn't there be 3 oxygens and 1 hydrogen? Water has H2O, 2 hydrogens and 1 oxygen. Hydrogen peroxide has 2 oxygens and 2 hydrogens. But we can't get a molecule that has 3 oxygens and 1 hydrogen. It just doesn't exist. Under extreme conditions, we might be able to force it to exist for microseconds or nanoseconds or something, but we're not going to consider that to be a stable molecule, and certainly Dalton wouldn't have known about something like that. But it doesn't explain why we have to have just these certain islands of stability where certain ratios work and others don't. We're going to have some extra pieces put into our model to allow that to happen. It also didn't bring up charged particles, and they knew about them at the time. Playing with electricity was one of the big parlor things to do if you had money and an interest in science. But that was all that it was a game, pretty much. Now, they knew that you had charged particles. This doesn't show charges at all, because we're not treating the atoms as divisible. We're saying that it's just a single block of oxygen. We didn't bring up that there's positive charges in the nucleus or that swarm of electrons around it with the negative charges. That's got to be built into our model later on. Now, I also want to point out that if we're following the scientific method, that means that we started with a good model, but we did further experiments and looked for more observations. We found that it didn't quite agree with nature, and so we had to do a refinement of the model. Now, there's also a couple more observations that didn't work with Dalton's model. It didn't bring up the existence of electrons, and I mentioned that that was a big deal. They knew about charged particles at the time, and they had done some experiments on electricity, and they knew about negative charges. They didn't know about the electron yet. In fact, the electron is one of the smallest particles we talk about, so that's still a long time coming. But it did imply that there were going to be things inside of an atom like a positive and a negative portion. They knew about that, but again, that didn't show up in Dalton's model. So we needed to have the next generation model that built in these new observations.